Wait, I'll just take out the text.
Okay, any question from the exercise?
Yes, there's a question. Um, so in question exercise 5B, question number 2, do we just do the drawing like the ones above?
Draw a diagram showing the quadrant in which the rotation of the line OP lies for each of the following angles on each diagram. Indicate clearly the direction of rotation and state the acute angle that the line OP makes with x axis. This is what the question is, right? So which part do you
Yes.
want to discuss?
So if it's for example, if I take part F.
Part F. Okay, so this is exercise 5b, question number 2, and part F. Part F is 2 pi by 3. Okay, so as we discussed that whenever we have angle in radian, so we always try to convert into degrees just to get the idea of the quadrant. So we multiply it with pi by 180 and 3 times 60, it is equal to 120. So after getting this degree angle, we'll be able to show it on the quadrant, and 120 O is this, P is a line, then this angle is equal to 120 degree, which is equal to 2 pi by 3. The first part is we need to show the line OP with the direction. With the direction mean clockwise or anti-clockwise, and then we'll find the acute angle which OP makes with x-axis. So this is the acute angle which is with the x-axis, and by looking into 120 we can say that acute angle is 60. So this acute angle is known as basic angle, and we know that in second quadrant we subtract any general angle from 180 to get this basic angle 60, and we can convert this basic angle by multiplying pi by 180 into radians. So it is pi by 3. So this 60 degree in as a basic angle, or pi by 3 radian as a basic angle but in the form of radians, right?
Oh,
Okay,
yes.
any other part?
No, that's it. But I would like, um,
Hmm.
I would like to revise the question number 1 on 5C. I feel like I'm
Okay,
still having a problem with it.
right. Okay. Exercise 5C, question number 1. Express the following trigonometrical ratios of acute angle. All right. But first, if I write sine of an angle uh, 90 minus A, and cos of an angle 90 minus A, and tan of an angle 90 minus A, right? So let me refresh this concept. At 90-degree we normally change the ratios, and changing the ratios at 90-degree and 270, we learned that sine of any angle changes into cos of an angle, and cos changes back to sine of angle.
Oh,
If we take tan of an angle, so it would be at tan of 1 over tan theta, or 1 over tan theta back to tan of theta. Okay, so basically in such cases we try to think of three things. Number one, by looking into the angle to figure it out the quadrant. So 90 minus A is the first quadrant. Okay, once you know the angle, then you'll write the sign, plus sign or minus sign. As we know that in first quadrant all the ratios will give you positive answer, then I'll put plus sign with all
Yes.
these because 90 minus a. Then I'll think of the ratio. Okay, and ratio is sine at 90 degree, this would change into cos. This is the second thing. And then this angle would be written with the ratio cos of a, and cos of 90 minus a becomes sine of a, and it becomes 1 over tan of a. But if I take,
So, how would the question for this first part look like? Would they give us an acute angle?
okay, all these angles are acute because we are taking a as an acute. If you subtract any acute angle from 90, you will be in the first quadrant.
Oh,
Okay, so
okay.
your final answer in the form of acute angle. But when I take 90 plus a, so adding acute angle to 90, you will go into second quadrant. Then in second quadrant sine will give you positive answer, and at this second quadrant sine will change at this 90 degree into cos, and cos will be written with the acute angle. Alright, for cos, the first thing is we'll look into the angle as we discussed that it would lie in the second quadrant. Then we'll think of trigonometrical ratio in second quadrant. Cos is negative in second quadrant, then we put minus sign. At this 90 degree, cos will change into sine, and its sign will be written with the acute angle. Tan is also negative in second quadrant, and at 90 degree it becomes 1 over tan of angle A. Okay,
Of
so these are the concepts for trigonometrical ratios in first and second quadrant when angle is adding or subtracting from 90. But if we have any angle which is subtracting from 180, so sine will remain as sine, and cos and tan will remain as cos and tan when angle is equal to 180. So 180 minus a, so we'll think about the quadrant would be second, and in second quadrant sine is positive, and there would be no change in ratio, and sine will be written in the form of an acute angle. Okay, 180 minus a is negative. If second quadrant, in second quadrant cos is negative, we put cos, and cos will not change at 180 degrees, and cos will be written with
so
acute
when it's so at 180 degree, none of the
ratio
angles
would
will
change.
change. They would
Angle,
remain.
yes, ratio will not change, and we put the sign of ratios according to the quadrant. As we are in second quadrant, and we know that cos is negative, tan is negative, we put minus sign. Okay, so this minus sign is with respect to quadrant. 180 minus a mean we are subtracting acute angle from 180 just to get the idea of the second quadrant. You can take any acute angle instead of a, like if you consider 30, so when you subtract 30 from 180, you'll be in the you'll get 150, and 150 lie in second quadrant. So in second quadrant tan is negative, so tan will give you answer tan of a, minus tan of a. At the same time, if I write sine of 180 plus a, so I'll think that adding an acute angle, let us suppose if I take a 10, when you
Okay.
add 10 to 180, you will move to third quadrant. If you
Oh,
take a 80, 80 is an acute, and adding 80 to 180, you'll get 1 260, and 260 is less than 270. Okay, so in
okay.
second quadrant your terminal line is 180, in third quadrant your terminal line is 270. So any angle which lies between 180 to 270 would lie in the third quadrant. So
Okay. Third.
okay, in third quadrant we know that sine is negative, cos is negative, tan will give you positive answer. So you'll take the sign according to the quadrant, and at 180 degree there is no change with sign, so it will give you sine of an angle A. Okay, so cos of 180 plus a is equal to minus cos of a, and tan of 180 plus a means third quadrant, and tan is positive in third quadrant, and tan will be written is equal to tan of acute angle, right?
So, where do we use these trigonometrical ratios?
Okay, now let us come to exercise 5c, and question number 1, its a part is sine of 190 degree. Okay, the
Okay.
very first thing is, as 190 angle is in the form of degree, and we are comfortable in showing 190 degree in the third quadrant, as we know that it is greater than 180, so definitely it would lie in the third quadrant. Okay, so once
Okay.
you show this angle into the third quadrant, then you'll find an acute angle of this line with x-axis, this angle. So what would be acute angle?
The acute angle will be 10 degree.
10 degree. Okay, now I'll write 190 is equal to sine of 180 plus 10. Now this
Yes.
is the case of sine of 180 plus a,
Yes.
right?
180 plus A, yes.
Okay, then the next step to this, I'll put minus sign because quadrant is third and sign is negative. Then I'll write sine because there would be no change due to this 180 degree, and we are adding acute angle to this. Then we'll write sine of 190 into the form of an acute angle. So sine 190 answer would be equal to minus sine 10 answer. This is what
So,
we are required to answer.
so the first step we do is uh, find the acute angle,
Yes,
and then we check which quadrant it is in,
yes,
and then we put the sign and check if it changes or not.
yes. Okay,
Okay.
now it is 305. The very first thing is, we'll find 305 location, and definitely this angle is 270, this angle is 360, definitely 305 is greater than 270. This is positive angle. Positive angle mean direction of angle would be anti-clockwise, and this angle is posed at 305. So whenever you find the acute angle, that acute angle must be along the x-axis. This angle we need to find. So what would be this angle?
So this angle would be wait, if that is 300, uh, it would be
Hmm,
55.
it would be 55. 55 is an acute angle.
Oh yes, it is an acute angle.
Okay, so if I write 360 minus 55, then whatever I'll get, that would be 305.
Yes. Okay.
So in fourth quadrant, you'll not write 270 plus this angle. Okay, we always find the acute angle with the x-axis,
Okay.
right?
With the acute angle, yes.
With the x-axis. So this would be the angle. So once you know the acute angle, then you'll think that this acute angle would be subtracted from 360, or 180 would be added to 360 or 180. So this is what we have to find, right?
Yes. Right.
Maybe you write 305 in the form of cos of 270 plus 35,
So yes.
right? So this angle is equal to 35, but the problem is, will find the basic angle. 35 is
Is
an
not
acute but
the
not
acute
basic.
angle?
Yes, because it is acute angle but it is not basic angle. Basic
Oh,
angle is an angle which is acute and along the x-axis.
oh, okay, okay,
So in every time and in every part we'll find the basic angle with the x-axis.
all
Okay,
right.
once you
Okay,
have that basic angle, then you think about writing 360 minus 55 by looking into this diagram, right? Okay,
right.
as we uh, discussed in last lesson, at 180 degree and 360 degree, all trigonometrical ratios will remain same.
So this will be positive cos because it's in
Yes,
the
it
fourth
will be
quarter.
positive cos of 55, so it is cos of 305.
Oh, okay. Okay. I
Okay,
understood that. Yes.
okay. If you use calculator, then you'll find cos of 305. You'll get some answer. But if you use basic angle of 305 with cos, you'll get the same answer. So
Oh,
the concept behind equality is this: you'll get the same answer.
okay.
All right. So if I consider like D part, it is cos of minus 245. Okay, due to this minus sign, we have to change the direction.
So
This
it
is
would be
minus
clockwise.
255. So if I started with 0, then in clockwise direction this angle would consider as minus 90 and this angle would consider as minus 180. This angle is considered as minus 270 and this would be minus 360 if you take a complete round.
Okay.
So minus 245 would be in the second quadrant. Quadrant's name would not change. First quadrant, second quadrant, third quadrant, and fourth quadrant. So when you start from your basic line and you'll move to this, so this angle is equal to minus 245. Okay.
Okay.
My question is now in this case, which angle is the basic angle?
The one from the x-axis.
And that
So the
angle
basic,
would be
the basic angle. Wait. So it would be 65.
it would be 65. Then I'll write cos of minus 180 minus 65 would be equal to minus 245.
Yes.
Okay, now cos is lying in the second quadrant. What is the sign, plus sign or minus sign of cos in second quadrant?
So because it's in the second quadrant, so it would be negative cos. No.
Then we'll put the
Uh,
minus sign.
and
Minus,
and
you're
because
right,
it took a 180-degree turn, it will remain the same.
remains the same.
So negative cos of negative
65.
65. Okay, 60.
65. Okay, okay, there's a small addition to this same part. I'll call it second method. Okay, once you find the quadrant minus 245, if I ask you to find this general angle, so can you tell me what the general angle is?
60. From there, it would be one 115.
So I can write cos of 115. So cos of 115 can be expressed as 180 minus 65. Okay,
Okay.
right?
There, yeah. Yes.
Okay. So cos 180 minus 65 means second quadrant. In second quadrant, cos gives you negative answer. At 180, cos remains same, and this is it. So the both ways are the concept for this question. So cos of minus 245, either you write it in clockwise direction, otherwise you can also convert clockwise direction equivalent to the anti-clockwise direction as I did in this step. Clockwise direction was minus 245 degree, anti-clockwise direction was 115. So once you have 115, then you'll be able to find the basic angle with x-axis, which is 65. Then 115 can be written as
Yes.
180 minus 65, and after this the concept is again the same.
Okay.
Okay,
Yes.
so definitely we have many things to be discussed in this chapter, and the same concept will repeat many times. I'm sure you'll be able to improve the concepts of finding the angles, right? So just for a little break, today we'll discuss the sketching of graph of sine, cos, and tan. Okay, sketching of trigonometric graph.
Okay.
The first thing is, before knowing the shape of a graph, I would do three steps. Draw, I'm writing draw, not sketching. Draw y is equal to sine of x, and the angle is from 0 to 360 degree. For this, I'll consider a table, and in the table I'll take the value of x, that would be an angle. For drawing, normally we take all the angles with the ratio of, with the difference of 30 degrees: 0, 30, 60, 90, 120, 150, 180, then it is 210, 240, 270, then it is 300, 330, and 360.
Oh,
Okay, the graph is y is equal to sine of x. If you use the calculator, then you will be able to get the answers in the form of decimal, right? So I'm doing
yes.
it directly, but you can check. I'm completing the table. You just take different angles, like on your calculator, sine of 0, and then see what is the answer. Sine of 30, sine of 60, and I'm writing the angle. You just confirm all the values. Okay, sine of 0 will give you 0, 0.5, 0.8, 1, 120 is in second quadrant, so zero point 0.5, sorry, zero point 0.8, ये point, yeah, zero point 0.8, 0.5, 0, and minus zero point 0.5, minus zero point 0.8, minus 1, 300, 300 is 60, minus zero point 0.8, minus zero point 0.5, and 0. This is it. this is 1 and this is minus 1. This is x-axis and y-axis, and this is origin. 0, 0.5, 0.8, 1, this, and this. Minus 0.5, 0.8, 270 minus 1, this, and this. Okay. When you draw a smooth curve passing through all the points, then you'll be able to get the graph of y is equal to sine of x, right?
Right. Yes.
Okay. This is a wave. Okay, we call it one complete wave. जी एक मिनट होल्ड करिएगा जी वालेकुम सलाम All right, sorry. So we were on the graph of sine of x. So after plotting all the points, we'll be able to draw the curve, and that curve would look like that it is a wave. So there are few more information regarding this graph. One would be from your previous concept. Okay. Yes. Noor, can you hear me?
Yes, I can hear you.
All right. The first thing is this information is known as domain. We know that is the value of x. And range, range is the value of y. If you look at the graph, your range value is, see, the maximum point of your graph is from positive side is +1, and the minimum value for the range on the graph is -1. So we would say that range would lie between -1 and 1. Okay, so range of the function would lie between these two values, number one. Number two, when you draw the graph, you'll get one complete wave. We call it one period. Okay, one period. So the term which we'll use in trigonometry, instead of saying it is a complete wave, we call it one period. So one period is in of the angle 360. So sine has one period of 360. Whenever we say that sine, sorry, period of a sine of an angle, so we say that period of sine of an angle is 360, right? So the first thing is the graph of sine. Next is draw a graph of y is equal to cos of x. Domain value is from 0 to 360, and for the table we'll say this is the value of x and y is equal to cos of x. So same values will be considered as 0. Next is 30, 60, 90, 120, 150, 180, 10, 40, 270, थोड़ी ठीक है, थोड़ी बनाएगा, 300, 330, and this is equal to 360. Okay, again I'll write the answers without using calculator, but you can confirm all these answers by using calculator. So cos of 0 will give you this answer, and it is zero point 0.8, this is zero point 0.5, cos 90 is this, 120 is minus zero point 0.5, minus zero point 0.8, minus 1, and this is 210, third quadrant, and third quadrant cos give you negative answer, and it is zero point 0.8, and then minus zero point 0.5, and it is 0, sine of 300. 300 is 60, so it is in fourth quadrant plus 5, and this is zero point 0.8, and cos of 0 is 1. 360 is 1. Plot all the values. Cos 0 is 1, cos 30 is 0.5, sorry, zero point 0.8, and then 0.5, 90 for 0, 120 is minus, and this 180 is minus 1, this is it, this is cos of 270. I missed 270. 270, and then 300, 330, and 360. Okay, and 270 for 0, 300 means 60.5, and this is zero point 0.8, and this is zero point 0.1. So when you draw a smooth curve which passes through all the points, then you'll get a shape of y is equal to cos of x. So uh, the same concept will say that domain value, and if we find the range, and we would see that y or f of x would lie between 1 and minus 1. So range of trigonometric function sine and cos would lie between 1 and minus 1. So this would consider as one complete curve, one complete cycle, one complete wave. So here we'll say that period of cos of x will also be same as sine of x. It will complete one complete cycle in the angle 360. Okay, now the next thing is, this was the second graph, and now we'll move to the third graph. Third graph is I'll write draw y is equal to tan of x, and I'm considering the domain between 0 to 360. Okay, x, and this is tan of x. We'll take the same time kind of angle: 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, and this is 300, 330, and 360. All right, so tan 0 will give you this answer. Tan of 30, tan 30. Yes, now I need your help.
tan of 30
Yes.
would be b root over 3,
Okay, and the decimal part of is
0.57.
0.6. So up to one decimal place we take zero point 0.6, and 10 of 60,
Be 1.73.
0.7. And what is 1090?
It says math error.
So whenever you have math error, you put an infinity sign.
Oh, okay.
And 120 is in second quadrant, answer would be minus, and minus zero point 0.6. 180 is 0, 210 is minus point, sorry, positive zero point 0.6, and 1.7, and 270 is again infinity, 300 is 60 and third fourth quadrant, so minus 1.7 minus zero point 0.6, and 360 is equal to 0. All right.
Why did we get a math error for 1970?
All right, so we'll discuss. Uh, if I take 30 and 60, 90, 120, 150, 180, it is 210. Okay, this is 1, 2, and so on. This is minus zero point 0.5, minus 1, and minus 2. This 10 0 for 0, it is zero point 0.6 somewhere, 0.60 is 1.7 somewhere. Okay, whenever you got this maths error at any value of x, you draw a vertical line that will pass through that point. So I'm drawing this vertical line to get this thing. Okay, in the table, as we consider few angles of the difference 30, 60, and 90. After 60 we directly move to 90. Okay, just do little numerical calculation, and I would need your help. If I ask you to find the value of 89, 10 of 89,
That would be 57.2.
87.2. Okay, okay. Now, if I find 89.9, then what would I get?
9.9, you will get 572.
572. Okay. If I ask you to give me the answer of 89.99, then
5,700.
5,799,
29.
57299.
729.
729. So, what are you observing? 89,
That
after 89 will move to 90, but I didn't move to 90. I took a number which is very close to 90, which is 89.9. And after 89.9, the normal perception is will move to 90, but I've considered another very close number to 90, which is 89.9. So as long as you take a number which is very close to 90, and you would observe that you'll get some answer, but that answer would be very, very, very large. So quickly you can take few more values which are close to 90 and see how much answer is increasing.
It's getting bigger and bigger.
Yes, this is it. It means that if we see, we are increasing on x-axis with a very small interval, very, very small interval, but what is happening to y value? We are getting very large jump. Okay, so each small step will get a very long jump vertically. This will give us the idea that if we plot the graph passing through the points which we are taking, then we'll see by increasing this line. If I increase this line,
It's going to be a very
yes,
long.
so when I plot the graph, it would look like that this curve will pass through the line, but it will never pass through the line. It will pass very close to line, side by side it will move. And when we magnified the graph, we would see that still there would be a difference between the curve and a line. Okay, so when vertical line is moving upward, we normally write it plus infinity. Plus infinity mean will take a very large value in such a way that is very close to infinity. So infinity mean will not get a point where the line crosses the x-axis. So in any graph, whenever you have this situation, your calculator give you math error. So what do? You draw a vertical line. That line will pass through the point at which you are getting this math error. And the concept behind is when you plot the graph, your graph will be very close to that vertical line, but never crosses the line, even touches the line. Okay? Did you get it? Yes. Is it clear now?
Yes, it is clear.
So instead of doing a very long calculation, when we have this undefined phenomena, we draw a vertical line, and normally that vertical line is in the form of dotted. We show that this is a dotted line. Dotted line means our curve will not cross or touch the line. Okay, so we draw a dotted line. Okay, okay, let's move to the next part of the table. After 90 we have 120. 120 mean 120 mean minus 1.7. 150 mean minus zero point 0.6. 180 mean this is 0. So when you join all these values, then you would observe that again your graph will pass through the negative part of that vertical line. It will move side by side but never touches that vertical line. Okay, this is the complete graph. So when we say that domain of a function for tan, so it would be any domain value. I mean from 0 to 180, 0 to 1 360, or minus, and from minus side, I mean we can take any value for domain. And what do we get? That our range value would be set of real number. Okay, because see that our graph is increasing from both sides. So increasing from both sides mean parallel to y-axis. It means when it is on positive side, so we'll get any value of y which could be positive, small or larger. And if we look at the negative part of y-axis, so when you relate it with your curve, so curve is moving ahead, so it will move towards very small value, very small value of from negative side.
Yes.
So we say that such function has range. Range is why we say that y belongs to real number, and we subtract all multiple of 90-degree angle. Multiple of 90-degree angle. And multiple of 90 degree of angle will not complete the statement. I would say that because 90 is the first and second multiple is 180, 270, 360 and 540. 180, 360. So alternatively you'll get an angle. I mean, tan of 180 will give you 0, tan of 360 will give you 0. After that you'll get the answer 0. But odd number of multiples. Odd number of multiples mean, so all the odd number of multiples 90, 270, 540. So at these angles you'll get maths error. So what do we do? We subtract those points from the real number. So this is how we find the range. Normally in the paper you will not ask to find the range for 10. Okay. Next is period. When I say period of tan of x, it would be 180. This is the period of tan of x. Okay. 180, it means it complete its one revolution in 180 degree. Okay.
So the period of 10 is 180.
Now we complete the table. After 180, 210 will give you answer point this, 270 will give you answer 1 point this, and again at 270 we get a line. At 270, if I draw a line, then we'll see that that line would be again, because it's giving mass error, so we draw this line in the form of dotted line. Okay. And when we complete our graph, and we would see that again the line will move towards to positive x-axis. After 270, 300 will give you minus 1.7,
So
0.6 and this. So this kind of graph will get in 360 degree. So this is the graph of tan of x. Now you can ask question. Okay. After drawing all these three kind of graph, when we are asked to find the sketch, drawing a graph is a bit difficult method because it takes time. We have to take all the values, but sketch is simple. All you need to remember is the shape of the graph. When it is sine, then you would get this kind of shape. When it is cos, you'll get some kind of bowl. Okay. And when it is tan, for tan, dotted line at 90 degree, and one part in the first quadrant will move up, and up to 180 degree that would be moved down. Okay, so these are the shape of the graph. So whenever you are asked to draw the sketch of graph, so all you need to do, sketch y is equal to sine of x. So when I take x-axis and y-axis, and you would see that it would be very easy work. I'll take angle, basic angles. I take only few angles, and those angles would be 90 degree. I'll take the all angles of difference of 90, 90, 180, 270, 360. Yes, only these angles I'll show. Then by using the calculator, the first angle would be 0. Sine 0 will give you answer 0.
Yes.
Okay. Sine 90 will give you answer 1. Sine
Yes.
180 will give you 0. Sine 270 will give you answer minus 1. And 360 would be this one. And as we know that shape of graph would be this kind of wave, so by knowing this shape, I'll draw and pass through all the points, and I'll get the shape of the graph. So this is the sketch of y is equal to sine of x.
Y is
Simple?
equal to sine of
Yes. Is it simple? Okay. For cos of x, 90, 180, 270, 360. This is 1 and this is minus 1. Okay, use calculator, give me the answer. Cos 0,
so
it is 1. Okay, cos 90, cos 90 is
0, 0.
0. Cos 180,
-1.
so you'll mark minus 1. Cos 270 again 0, and cos 360 will give you one answer. And the shape of cos would be of this type. Okay, so all you draw the graph will pass through these points, but try to keep the shape same. Sketch mean a curve which is very close to original one. So this is the graph of y is equal to cos of x, right? So sketching is more simple as drawing. So you'll not ask to draw the graph. You'll always ask to sketch the graph. So always sketching is simple. So in case of tan, 180, 270, and 360. So whenever you draw the graph, you draw some lines at which your graph will give you infinite or mass error, and mass error would be on these angles. Then we know the shape of the graph for tan is one curve would be this one, and this is the dotted one, and this would be the second curve. So directly you can show it the graph like this. 180 to onward it will move down. After
Okay.
180, after 180 the shape of the graph would be just like this one. Okay, so just try to again sketch it same as to this tick one graph, and 360 would be same to the lower part of graph as we draw it from 180 to this one. So this kind of graph. So you can see that by trying sketching a graph of tan of x is simple.
Yes.
Okay. All right. Hmm. If I ask you to find sketch the graph of sine of x plus 1, what kind of transformation is this?
Translation.
Translation, vertical or horizontal?
This one.
Hmm? One is adding outside of a function.
Of
Y
the
is equal
it's
to f of x plus 1.
the one outside vertical.
It's vertical. So what do we do?
We move the graph 1 unit to the right.
1 unit to upward. If it is
Upward. Oh
vertical, then
yes.
it will move 1 unit upward. So this is 2. So all the points will move 1 unit upward, 1 unit upward, 1 unit upward, and this will 1 unit upward comes here, and this will 1 unit upward here. And I would suggest whenever you are adding or subtracting a number outside of a function, you draw a line. I call that line a basic line. So draw a basic line which passes through y is equal to 1. So this is a baseline. So from this baseline, you'll be able to sketch the graph very easily. So we are shifting the graph 1 unit up, and we have shown the points. When you sketch the graph which passes through the point, then you would get a graph y is equal to sine of x plus 1. So same thing will be applied to, like, y is equal to cos of x minus 1. Minus 1 mean we shift the graph 1 unit to downward. So minus 1 mean we draw baseline which passes through minus 1. So we call it a baseline. Once you draw the baseline, then you shift the point 1 unit to downward, 1 unit to downward, this one. And when you shift this point 1 unit downward, it come here, and 1 unit is this one at this point vertically downward. So when you draw the same sketch, you would get a graph of y is equal to cos of x minus 1. So whenever you draw the graph, do label the graph with the equation.
Oh,
Okay. Okay. Y is equal to sine of x. 90. For simple sine graph would be sine 0 0, sine 90 is 1, this minus 1, and this. Okay, when I sketch the graph which passes through all the points, I'll get this kind of graph, and I'll name the graph with the equation y is equal to, this is y is equal to sine of x. Okay, if I ask you to the graph of y is equal to 2 sine of x, so what kind of transformation is this?
It is it is a stretch.
It is a stretch parallel to x-axis or y-axis.
And the y-axis.
Parallel to y-axis, and what is the stretch factor?
It is 1/2.
No, it is 2. For vertical stretch factor, y is equal to a time of f of x, so stretch factor is a. Any number multiplying outside the function, that would be same as the stretch factor. Do you remember the working rule for vertical stretch?
The this would be we multiply the domain by 2.
No, range by 2.
The range by 2, yes.
Scale factor will multiply with y coordinate. All right, so the y coordinate at this point is 1. When you multiply it with stretch factor, so this, you'll get the new point. This would be the same as it is, and minus 1 will move to minus 2. 180 would be this one. So when you apply stretch to the function, then you would observe that this is a stretch. Okay,
Okay.
in trigonometry, whenever you have y is equal to sine of x, you we know that it is a stretch. We know that it is a stretch.
Yes.
But in trigonometric function, we call it the amplitude of sine. Okay, so for, if I ask you to find the amplitude of sine of x, then the coefficient of sine of x is 1. If we are finding the amplitude of sine of 2 sine of x, then amplitude would be 2. Amplitude means the maximum point from the baseline. This is the amplitude. Okay,
Oh,
all right, so to little extent, if I want to find y is equal to 2 sine of x plus 1, then what would we do?
if it's plus 1, then the amplitude would go up by 2 and it would vertically translate to 1 up.
So y is equal to 2 sine of x. This is the graph. Plus 1 unit means we draw a baseline which passes through positive 1 on y axis. So this is the baseline, and sine 2 sine x graph will be translated 1 unit vertically upward. So all the points on this orange graph will move to 1 unit upward. 1 unit upward means this one, and this becomes this one. All right, so when you shift this 180 point to 1 unit upward, it becomes on baseline, and this point will move and reach at this point, and this will move to this point. So all the points with green color, we sketch a curve which will pass through the points. Okay, so it is like this and this one. So I'll write the equation 2 sine of x and plus 1. Okay,
Okay.
so we'll apply all kind of transformations in the functions. Okay, now y is equal to cos of x. 90, 180, 270, and 360. This is 1, 2, 3, minus 1, minus 2 and minus 3. Okay, the first thing is cos 0 for 1, cos 90 for this, 180 for minus 1, this, and this is it. Okay, if I sketch, so this is y is equal to cos of x. Okay, if I ask you to draw the graph of y is equal to minus cos of x, what kind of transformation is this?
A reflection.
It is a reflection in the line. Which
It's
line?
outside. It's inside the.
It's outside the function.
It's outside the function, so it would be a vertical
Vertical.
reflection. So it would be across the
Vertical reflection in the line
y.
x-axis.
Oh, x-axis.
Okay, it would be on x. Okay, so what would be the working rule for vertical reflection?
For vertical reflection, we take the y coordinates and turn it into negative.
Yes, so we replace y with minus y. So this point would be reflected in the line, and 90 would remain as it is because it is on the mirror line, no change. 90, this point has y coordinate minus 1 and it becomes plus 1, and again this would be remain same, and this point has y coordinate 1, so when you reflect it, it becomes minus 1. So this kind of graph you'll get for y is equal to minus cos of x. Okay, so these were the examples of vertical transformations: translation, reflection, or the stretch. Now we consider example of 2x. 2x means this would be the example of f of 2x. When any number is multiplying inside the function, we call it a stretch. Horizontal stretch, parallel to x-axis, and stretch factor becomes 1 over 2. Okay, so basic of that angle remains same. Now we'll see that what kind of change we'll observe. We consider the same angles: 90, 180, 270, and 360, right? Whenever
Yes.
any number is multiplying with x, so you take the interval by checking 90 is the difference, divide that number 2, 2 is multiplying with s, then 90 divided by 2 mean 45. So you'll use the calculator, you'll not show the working on the graph, but use the calculator to find all the values of the difference of 45. How? Right, okay, let me share it on your calculator. Can you see the calculator?
Yes.
All right. So you'll do, you write sine, okay, 2, then press alpha, and this red, in red color you find this letter X. Close the
Yes.
bracket. Okay. Now press the word this button with the word calculate. When you press it, then you'll put the values, like when you put 0 and with equal sign you'll get 0. Okay, so one by one I'll place all the values. This is 1, this is 2, this is minus 1, and this is minus 2. 0 for 0. Now I need to find this angle which is lying between 0 and 90. That would be 40. So on the calculator, I'll again press a button calculate, then write 45, and when you put equal sign, you'll get 1. So at this 45, you place this point. Okay.
Yes.
So each time by doing the same working, by pressing the button calculate and next angle is 90 and equal, you'll get 0. So likewise, when you take all the values, you'll get this kind of graph.
Okay.
Now you can see that you have obtained a graph of sine with 2 cycles.
With 2 cycles?
Yes. 2 cycles mean 2 period. So whenever we say that period of sine 2x, so you can see that one cycle is completed within an angle of 180, then the period of sine 2x would be 180.
Yes.
Hmm? Is it
Yes.
clear? Okay. So similarly, if I want to find the period of sine 3x, can you tell me the period of sine 3x?
The period of sine 3x would be 2 root over 2.
Okay, period of sine x was 360. When it was
Yes.
2x, then we divide 360 by 2 to get 180. When it is 3x, then we find the period by dividing 360 with 3, will get 120. This 120 mean will get the period, I mean will get a one complete cycle within an angle of 120. Okay, so if I want to find the period of sine 4x, what I do, I'll divide 360 with 4 and I'll get 90. So in 90-degree, I'll get one cycle. So from here, if I give you a general formula in general, period of sine nx, that would be equal to 360 over n.
So, okay.
Okay. Okay, if I sketch a graph of sine x, let's see what kind of graph I'll get. Sine 0 for 0, sine 90 for 1, 180 for this, 270 for minus 1, and this is it. So I'm getting the graph of this shape. Yes, this is it. This is the graph of y is equal to sine of x. This is the graph of y is equal to sine of 2x. Okay. If I write the working rule for horizontal stretch as we did in the transformation, if we follow that rule, 270 minus 1. So the working rule was the stretch factor is 1 over 2. What do? We multiply stretch factor with x coordinate, right?
Right.
Now check this point. This point has coordinate 90 and 1. 90 and 1.
Yes.
So x coordinate is 90, stretch factor is 2, x coordinate is 90, it becomes 45. Then y coordinate would remain same, the point becomes this one. So we have done x coordinate is moved to 45 degree. Is it clear? So take, if you take all the points, next point is 180 0. So after horizontal stretch it becomes 90 and 0. Look at this point. Next point is after on this black graph, which is 270 and minus 1, when you divide 270 with 2 it becomes 135 minus 1. Okay, after this the final point was 360 and 0. When you transform by using horizontal stretch and x coordinate is 360, when you take the half it becomes 180 for 0.
So 360 will go into 180. Yes.
All right, so the first point was 45 and 1. Just figure it out. This point has coordinate as 45 degree and 1 y-axis. Okay, next point was 180 and 0. This is the point which is 180 and 0. When you applied horizontal stretch, the new point was 90 and 0. This is that new point which is 90 and 0. Okay, 270 minus 1. 270 minus 1 on black graph is with this 270, and minus 1 on x coordinate, when you multiply it with 1 by 2 stretch factor it becomes 135. Now figure it out. This is 135, y coordinate is minus 1, so this is the point with 135 and minus 1. Finally 360 and 0, 360 and 0, this is 360. When you divide it with 2, I mean multiplied with stretch factor 1 by 2, you get 180. 180 is this one. So this graph is become one cycle of sine of 2x. Is it clear?
Once. Yes.
So this is how we apply uh, transformation on trigonometric functions. In next class, inshallah, we'll discuss uh, horizontal translation, number one, horizontal reflection, and the by discussing these 2 points, and then we'll move to exercise and do some questions of sketching. Okay, so till that revise all the exercise regarding this trigonometry, and there are many points which are new concepts, so I would like you to revise before the next class. So keep revising the things and then you'll be able to perform well. Okay,
Okay.
all right, take care till next class. Love is.